Hello everyone, welcome to this video where we're going to discuss some of the clone past year questions on the chapter differentiation, which is in the new syllabus KSSM is Form 5 chapter 2. So in this video we're going to focus only on the paper 2 types question, and for this problem solving question they expect you to know how to use differentiation to solve the problem, and I will explain to you how do you know when you need to use differentiation to solve this type of question. Okay, we look at the question here. Diagram shows the front view part of a roller coaster. So the curved part of the track of the roller coaster is represented by this equation. Yeah, so the track here, this curved part here, the track is represented by this equation with point Q as the origin. So actually this is the point Q here. Okay, find the shortest vertical distance from the track to the ground level. So actually the ground is here. So we want to find the shortest vertical distance from the track to the ground, means we want to find this, the shortest vertical distance. As you can see here, at the lowest point of the track, the distance between the track and the ground is the shortest. Hence, this is the distance that we are looking for. That is the shortest vertical distance. And if we look at this question again, it says Q is the origin. So if we represent the diagram on a Cartesian plan, you will have something like this. And since we are looking for the shortest distance between the track and the ground here, if we are able to locate this point, if we are able to find the coordinates of this point, in other words, we will be able to find the y value here. If we are able to find the y value, we will be able to identify the distance between the origin and here, hence the height or the distance between the origin until this point here. And then, since from the origin to the ground level is 20 meters, we take 20 minus this, we get to find the balance, the rest of the distance, which is the shortest vertical distance here that we are looking for. Now back to our question here. How are we going to find the coordinates of this point? Since this is the lowest point, this is the minimum point. In order to find the minimum point, we know that for a given curve, at the minimum point, the tangent is a horizontal line. And since the tangent, this is what we call the tangent, is a horizontal line, the gradient of the tangent equals to 0. Because it is a horizontal line, so the gradient is 0. So the gradient of tangent is 0. And how do we find the gradient of a tangent? By using differentiation. So here, if we take the horizontal distance as the x, if we take the horizontal distance as the x, and we take the vertical distance as the y, hence the gradient of the tangent will be dy dx. We differentiate y with respect to x, which is equals to 0. So we differentiate this equation. Y equals to 1 over 3 x to the power of 3 minus 2 x to the power of 2. We differentiate y with respect to x. We find dy dx. You get this. So you take the 3, multiplying 1 over 3, you get 1. And then the 3 itself minus 1, you get 2. Next, 2 multiply negative 2, you get negative 4. Then the 2 minus 1, you get 1, which you don't have to write here. And at the minimum point, dy dx equals to 0. Hence, x squared minus 4x equals to 0. In order to find the value of x, we factorize this. You get x minus 4. So x equals to 0, or x minus 4 equals to 0, x equals to 4. Okay, so now there are two values of x. Which one is the one that we are looking for. Okay, so again, remember, because Q here is the origin, if we draw the x-axis and the y-axis here, as what I've shown you just now, x0 will be here. So x equals to 4 will be here. This is x4. Hence, we take x equals to 4 instead of this, because this one is referring to this. So now, for x equals to 4, we substitute this into the equation here in order to find the value of y. You get this or negative 10.667. Either one. So in this case, I'm using the fraction here. But this is not the final answer because we only get the y coordinates, which is the y value, which is here. Here is negative 32/3. But then we still have to take 20 meters minus this. Because the 32/3 here represents the distance from here until this point. So the shortest vertical distance, equals to 20 meters minus the distance here, minus 32/3, which you will get 9/1/3 or 9.333 meters. Okay, so it means that from here to here, the distance here is 9.333 meters. Question number 2. Diagram shows the front view of a window. The arc of a window, so the arc here is a semicircle. So since this is a semicircle, means half of the circle, hence this will be the diameter. Since the width here is 4K, diameter will have a length of 4K, and if we want to find the radius, which is half of the diameter, which is half of 4K, will be 2K. The perimeter of the window is 8 meters. Okay, the perimeter means the total length of the side. So this plus this plus this plus this. Now, express the front surface area of the window in terms of K and pi. The front surface area means the area of, okay, the total area goes to the area of the semicircle plus the area of the rectangle. Area of the semicircle, area of the rectangle. So area of the semicircle is half, right? Semi means half of a circle, so the area for the circle is pi r squared. And the area of the rectangle will be length, height times width, or the length times width here, which is 4hk. H times 4k will be 4hk. However, the question asks you to give the answer in terms of k and pi. So we only want k and pi. We don't need r and h. We don't need these two, so we have to substitute the r and h by using k. It says the perimeter of the window is 8 meters. Perimeter is h plus 4k plus h plus the arc, given as 8 is actually the h plus 4k plus h here. So it will be 2h plus 4k. And then the arc length of the semicircle, which is half of 2 pi r. 8. So we try to simplify this. Again, here we have another r here. So we come back to this semicircle here. As I already told you that the radius is half of the diameter. So this is the radius. So the r equals to 2k. So we are going to substitute the r here with 2k. So you get h. So since we are going to substitute the h with k, from here we try to write h in terms of k, so that we can substitute into the main equation. So I move all of this to the other side. I get 2h equals to So I'm going to substitute h with this into here. So the r here again, we use 2k because the radius is 2k. 4 and k, 4 and k multiply into all the terms inside the brackets. K minus 4 pi k squared, I get negative 2 pi k squared. So that is the answer for A. So for question B, by using pi equals to 3.142, find the width of the window when the front surface area is maximum. Okay, so here, again, no word about differentiation is mentioned here. How do we know that we need to use differentiation? We come back to this equation here. This equation, I use a blue color. This equation shows the total area, the total front surface area in terms of K. And you can see that K here is squared, means this is a quadratic equation. If we try to express this on a Cartesian plan by plotting the graph of A against K, right? Because the two unknowns here, the variables here is A and K. Pi is a constant. So if we plot A against K, since this is a quadratic equation, you might get a parabolic curve. It's either like this or maybe it's this. So since you can see that the coefficient for the k squared here is negative, it will be graph like this with a maximum point. At the maximum point, we learned that the tangent, the gradient of the tangent is 0. And how do we find the gradient of the tangent for a graph of A against K here? It is by using dA dk. Yeah, we differentiate A with respect to K. So if we can find dA dk and we equals it to 0, we can use this to help us to find the maximum surface area by finding the K value at this maximum point. If you have problem understanding this part, there's a general way of remembering this. Whenever the question involves area or volume, usually, and you are required to find the maximum or the minimum value, you use differentiation. And depends on what variables is given. Like for example here, if A and K are given here, we have to use dA dk. So now I try to differentiate A with respect to K. I will get this. Okay, I'll get this negative 4 pi K, and then this one multiply this, I get negative 16K. For this part, I will get 16 only. And at maximum point, dA dk equals to 0. So negative 4 pi k minus 16k plus 16 equals to 0. And you can see now we can find the value of k. Substitute the 3.142 into the equation, I can get this is just for the value of k. So the question asks for the width. So this is the width. The width is 4k. Huh? So width equals to 4k. So 4 times 0.5601, which is 2.2404 meters. Now we move on to another question. Here, this is similar to question number 2, where you need to find the volume of a cylinder, and then you need to Find the value of H and K such that the cylinder is maximum. Diagram below shows a rectangular cardboard. Okay, so we have a rectangular cardboard here. It is used to form an open cylinder with the height. Okay, so if this cardboard, we roll the cardboard, it will form a cylinder such as this, where the height here is still the same, and then the length here, the K here, becomes this, the circumference. The circumference is K. And since the circumference is K, the formula for circumference is 2 pi r. 2 pi r. Given the perimeter of the cardboard is 100. Yeah, so the perimeter of the cardboard here means K plus H plus K plus H equals to 100. Okay, so the first thing here, we need to show this, where V is the volume of the cylinder. Okay, so V is the volume of cylinder, and when we look at this part here, we'll notice that it only has H, means we are showing V in terms of H. There is no K given here. Okay, so we start off with the volumes formula, the volume of a cylinder. So volume of a cylinder is equals to pi r squared, which is the area of the base, the area of the circle, times the height, h. Since we need to show this, we need to substitute the r, yeah, in terms of h. So here we already know that r is related to k in this equation. So here we already know that r is related to k by using this equation. So we can write this as 2 pi r equals to k. So r equals to k over 2 pi. But if we substitute this into this, there is still k inside. From the given question here, there's no k involved. We try to substitute k with h. This, we have been told that the perimeter is 100. So h plus k plus k, 2h plus 2k equals to 100. Since we want k in terms of h, so I move the h to the other side, I get this. Now I can substitute this into this one. Okay, so here V equals to pi r squared. R is given as k over 2 pi. Yeah, R is this. And then the k here, we can substitute with 50 minus h. And now we have V in terms of h. And we just only have to simplify this, factorize this in order to show this. So I just take this 50 minus h squared. So the squared applies to both the numerator and denominator here, so it becomes 4 pi squared. The pi and the pi cancel, so I'm left with h, this h here, over 4 pi times 50 minus h squared, which is here. So it's proven. For question B, find the value of h and k such that the volume is maximum. So just now I already told you that when you deal with questions which requires you to find the area or volume, maximum or minimum, we use differentiation. So I expand this part, I will get this, and then I multiply this so that it is easier. I expand all of this so that it's easier for me to do the differentiation. So I perform the differentiation. I differentiate V with respect to H. Turning points. Okay, the turning points is either maximum point or minimum point. At the turning points, dV dH equals to 0. So we now try to equate this to 0. I write at the other side here. So I multiply the all with pi, I'll get 625 minus 50h plus 3 over 4h squared. I multiply all the terms with 4. In order to get rid of this 4 here, I'll get, rearrange this first. Now you can use calculator, you can use a fraction factorization, you can use a formula in order to factorize this. And so 3h minus 50 equals to 0, h equals to 50 over 3, or h minus 50 equals to 0, h equals to 50. So now the problem is we have two h value. Which one should we take to find the maximum value? Of course, you can substitute both h into the volume to find the bigger volume, or there is another way, which is by using the second derivative. We differentiate this for a second time. Yeah, so we differentiate v with respect to h for a second time. Yeah, we find d2v dh squared from here. We will get, so why are we using second derivative is because when we substitute the h value into this equation, if we get the values less than 0, it means the h value is from a maximum point. If you get the value less than 0, more than 0, it means that the h comes from the value of a minimum point. Okay, so we try to substitute this inside here. Yeah, when h equals to 50 over 3, negative 7.957. Negative value is less than 0, hence it shows that the h is maximum. And then of course you can try to substitute the 50 inside here and repeat the whole process here. You will get the value is positive, which is minimum point. So since we are looking for the maximum point, yeah, we take h equals to 50 over 3. But then the question also asks us to find the value of k, so we substitute the h into this equation in order to find k. So k equals to 50 minus 50 over 3, which is, if it is in decimal, it is 5.30.